Okay, so now in this part of the lesson, we are going to be looking at this goal where we analyze a Cartesian graph of y equals f of x, looking at its interesting key features in order to be able to construct the corresponding polar graph. So we'll use a different approach now for these ones. So a portion of the graph r equals f of theta, where f of theta is 3 cosine 3 theta, is shown in the polar coordinate system between a and b, where a and b are between 0 and 2 pi. Which of the following could be a and b? What we want to do for this one is we want to sketch the Cartesian graph first. So we've got a cosine function. Cosine function looks like this. These points are 2 pi, pi over 2, 3 pi over 2, and obviously 0. So sketching the transformation of that one, it's going to look like this. Our endpoint, so 2 pi divided by 3 is going to give us 2 pi over 3. Pi divided by 3, pi over 3. Pi over 2 divided by 3, this point here is going to be a pi over 6. And this point here is going to be 3 pi over 2 divided by 3, which is pi over 2. Our graph looks like that. So in order to go from here to here, most of these start at 0. So let's look at these three to begin with. Do we want to stop at pi over 2, pi over 3, or pi over 6? Let's go from 0. We want to be all positive. So we want the Cartesian graph to be positive all of the time. That means we need to go from 0 to pi over 6. And here is the correct answer. If we test endpoints, we'll be able to exclude these two. But testing endpoints on this one is a little bit trickier because it is going to produce the values 3 and 0. But it's also, you're not testing the points in between. What's going to happen on that one when we go from pi to, where is pi? Pi to 3 pi over 2. It's not on my graph here. It's going to be covering multiple points. So it's actually going to be giving me something like this. So just testing endpoints isn't always going to be the way to do it. Having a little sketch of the Cartesian will help us. Okay, so what we've got now is this obviously it's going to be a cosine function. We've got 6 cosine 3 theta in the polar coordinates. We have the points A, B, C, and D. If the domain of f is restricted to pi over 3 to 2 pi over 3, which portion of the graph are we going to be, restricted? The portion of the graph given remains in 2 pieces. One of these pieces is in the third quadrant from C to D. So one of these pieces is here from C to D. Where is the other piece? Well, the other piece is either going to be this bit here or it's going to be this bit here, depending whether it lies either side. So let's have a look at that. I think the easiest one for us on this is to calculate the end values. Let's have a go at calculating the end values for this one. We want f of pi over 3, which is going to be 6 cosine 3 times pi over 3, which is going to be 6 cosine pi. Little sketch again. I think that's pi, isn't it? This is 2 pi. So this is going to be 6 times negative 1, which is going to be minus 6. So when we are pointing in this direction at pi over 3, we want to be at -6. So that's this coordinate here. So C is there. And then when we go for 2 pi over 3, we're going to get 6 cosine 3 times 2 pi over 3, which gives us 6 cosine 2 pi, which is going to give us +6. So 2 pi over 3 points in that direction. So we're going to be there. So the first half of the graph is from pi over 3 to pi over 2, the blue bit. And then the second part of the graph is going to be from pi over 2 to 3 pi over 2. Sorry, 2 pi over 3 here. So we are going from D to, we are going to go from D to A. The portion of the graph is in the second quadrant from D to A. This is the correct answer. Right. So the polar function r equals f of theta, where f of theta is 2 over theta. We don't have a trigonometric function here. It's defined from 0 to 1. Which of the following describes the polar system? So we want to start with our Cartesian. We can sketch this function. This is a reciprocal function. It's going to start up here at infinity and come down in this direction until we get to our end point here, which is going to be at 1, 2. When theta equals 1, if this is theta in this direction, and this is 2 divided by theta, or y equals 2 divided by theta, we're going to start off at infinity, and we are going to come down to the coordinate 1, 2. Now, sketching that in the polar system, we've got our circle like this. So as we rotate round from 0 to 1, so here is 3. So we're rotating around in this direction. So when we're at 0, we are all the way over here, massive values. So these values are going to come in and head in like this until we get to a point where the vector is pointing out in this direction at theta equals 1. And then the coordinate there is going to have the length 2. So the polar coordinate here is going to be 2, 1. R is 2 and theta is 1. What this graph is actually going to do is going to spiral around like this. So we can see that it's curving. So looking through our different answers, it's not going to be a line. It's not going to be a line. It's not going to be a line. It's going to be a spiral. One of these two, for which increasing angle measures correspond to a decreasing radii. Yeah, they're going to be getting closer and closer. They're not going to be an increasing radii. So our correct answer for here is going to be C. Let r equal f of theta be a polar function where f of theta equals 5. The graph of r of theta for the interval from 0 to pi appears as a semicircle. So if you think about this, what we want to do is let's sketch the Cartesian graph of this. So if we sketch the function y equals f of theta, this is theta, this is y, we're going to get a horizontal line like this. So sketching the polar graph, we've got a radius which is always 5, from 0 to pi. we'll get a semicircle like this. We need to complete the circle in this direction. And we need to go from, so if we go from 0 to pi, for pointing in this direction, we just check the different answers. So the graph of, sorry, we're not completing it. Which of the following graphs of the polar coordinate is the same? All right, no. Okay, we're not trying to compete it, we want the same bit. So that this first graph here from this with the same angles is going to complete it. It's not the one we want, it's going to be these ones down here because we're going to be pointing in the opposite direction. So as we go from here to here with our angles, I'm looking now at this one, we want to be going in the opposite direction with -5. So this one is going to be C. The graph of the polar function r equals g of theta is given with g of theta equal to 4 cosine theta plus pi over 3, given in the coordinate. Which of the following descriptions is true? So let's just read the descriptions a little bit. Values of theta for the interval pi over 2 to pi correspond with the portion of the graph in the first quadrant. All right, so what we're looking at here on these ones is, in each case, it's the same interval. It's the same interval. And we need to figure out, for this interval, which quadrant it's in. It's either the first, second, third, or fourth. I think the easiest strategy for this one will be to sketch those two endpoints and see where they are. So let's try for g of pi over 2. That's going to be 4 cosine pi over 2 plus pi over 3, which is going to be 4 cosine, let's do this over 6, 3 plus 2 pi over 6, which is 4 cosine 5 pi over 6. This is going to be, let me just think my cosine values, that's going to be a half minus a half. So this is going to be 4 times minus a half. Let me do a unit circle. Tell me, I'll make sure I'm not getting this wrong. Here's our unit circle. Our angle is over in this direction. Yeah, that's minus a half. That's 5 pi over 6, which is going to give us minus 2. So plotting that point now, that gives us the polar coordinate minus 2 comma 5 pi over 6. So 5 pi over 6 is this direction. And we want it to be minus, that looks wrong. I've got something wrong here. Let me just do let me see if I can find my problem. So we've got pi over 6, pi over 4, pi over 3, pi over 2, 0, cosine. That's 1, root 3, there we go. I can see where I made my mistake now. There's our exact value table. So 5 pi over 6 is going to be root 3 over 2. Made a mistake there, spotted it. I spotted that mistake because as I tried to trace this across, I'm not at minus 2. So I see I've made a mistake. Nice one. So we need, removing that, this is supposed to be root 3 minus root 3 over 2, which will give us the value minus 2 root 3. Now, minus 2 root 3 is something around about here. That looks right. Let's try the other one. We need g of pi, which is 4 cosine, what was our function? We'll just check it, pi plus pi plus pi over 3. That is going to be 4 cosine 4 pi over 3, which is this one here. No, it's not. That's 7 pi over 6, this one. It's going to be there. That is going to give us it's going to give us 4 times minus a half, which is equal to minus 2. So this was when we're at pi, and I'm pointing in this direction now. I need to be minus 2. So this part of the graph is there. We are in the fourth quadrant. Okay, that's it for today.